Okay, so for the head, I missed the depth of the thread here was 3.25. So again, kind of looking through. Oh, they gave us a 0.25 radius there too. So yeah, I think the 0.125s are fine. That blend, yeah, we could probably add that one in as a 0.125 and let it roll over, but don't see any great need for that to be 0.25, so we'll just let it blend out there. Since we had the cut sweep is built on the cut revolve, then I'll pick up the shoulder and we'll give it a depth of 3.25. But as far as the thread, I'm not too concerned. Let's look at it in section view. So using the front plane, we're pretty close. We might get one more thread length, but the whole purpose of the left-handed and the right-handed threads at the opposite end of the tie rod is so that as you turn the tie rod, it adjusts the head and the fork either closer together or away from each other. So I think there's enough adjustment in there. We can call it out on the print. So we'll do one more save. And then I mentioned that we'll be using the hardware from the toolbox. So let's go into an assembly. We'll open up our new assembly. Doesn't really matter. I was thinking I'd like to have the fork at the origin, but the head is fine. So if we bring the head in and kind of move it around wherever I click, it's not going to be on the origin. So I didn't mention this with the milling jack, but the reason that we would want our assembly to be at the origin is because that is the default of the center of mass calculations, or the engineering. When we do the evaluate and do the mass properties, it's going to take those values from whatever we pick to be at the origin. Now we can create what's called a coordinate system and put that coordinate system anywhere on the model to have it calculate those values. But if we have some part related origin to origin, that's usually a benefit. So let's go ahead and when I come over to the check mark, I'm not clicking out into the work area. I'm just coming over and clicking on the check mark. If I move back into the work area and the head or the part component is allowed to move, and then come over to OK, that's going to put the origin of the part. There's the origin of the assembly, and there is the origin of the part. And because of the way that I drew this, I can leave this fixed. We don't have to right-click and float or do anything like that. It is in the orientation that I want it. So the next item would be, let's look at the File Explorer and we'll see what's open. All right, so I haven't saved anything yet. And Assign8 apparently hasn't updated to show the new folder, so I really should see if we collapse that. There it is, 1341. So last thing we'll do is we'll gather all of these up and put them in their own 1340 folder. All right, so the bushing I can drag in. And for the next go around, we'll create some mate references so that those kind of snap together. Going to make the bushing concentric, and then the face is coincident. All right, and then in this case, because it's able to rotate, that's a problem because I said we're going to try an assembly feature where we do that quarter 20 set screw. All right, so in this case, I want to identify my front plane. And what I was looking at is if this is capable of rotating. We come back to the front plane now, it's in a different position. So what I'm going to do is locate it in relation to the head so that they stay together. Most of the time we could just go ahead and place the concentric. We would just say lock the rotation. But this is a little more important because we're going to tie that geometry to it. All right, so we're going to come back to that one. Let's go ahead and insert the tie rod. And we're going to insert, I'm kind of doing this backwards. We went to the File Explorer, now I'm going to the pull down, insert component, existing part and assembly. We're browsing to the tie rod. All right, since that comes in as so long, that might be a problem. We have some direct editing that we could do. And we may want to go ahead and suppress those threads because that's going to be kind of painful to have redo every time, but recalculate it. All right, so 19, let's go ahead with the 3 inches. And then the issue is that I can't really pick the threads. There's not much of a cylinder there, so cylinder that I can pick, the outside and the outside. So we're going to control select those and then tell it that they're concentric. So that engages the thread. And I'll go back to control 1. Let's go ahead and section this through the front. And one of the questions I get all the time is, are those threads going to line up? And actually, for once, they didn't do too bad. I'm impressed. Most of the time they're off by a little bit, but if we started both of them at 0 degrees, then yeah, they should be pretty close. All right, so it's not a given, and I'm not worried about them being sized that way. All right, so the issue here is that if I needed to put a thread mate onto this shape, that becomes a little bit more complicated, but it would be interesting to see as I turn the tie rod that this moves that way and the fork moves that way. All right, so we're just going to leave this as a static and won't do too much in the way of advanced mates. So browse, come back and bring in the fork, place it, and from position, we had 4 inches overall. We have 3.875 in thread. So I'm going to do the same thing. I'm going to set a distance mate, 3.875. And we want to flip that dimension so that it's engaged. Go ahead and accept it, hit OK. And then I'll control select. And those 2 ODs then can be engaged. Now this one, because it was just the annotation, the cosmetic thread annotation, not as much detail. All right, so the front plane of the fork going to the front plane of the assembly is going to be parallel. And it could be coincident, but I like parallel because if there is an issue, and why didn't that go parallel? Should have rotated back. Didn't take the parallel. All right, so let's try again. Front plane. As parallel is easy to define or identify because we don't use it as much. So being able to use it as a flag is kind of a good function. All right, so we're not going to have as much to assemble on this one until we get into the to the hardware. But the geometry is still pretty complex. All right, so we brought in the 3 from the File Explorer, the pull down, assembly. Let's go ahead and open recent, and I want to open up the pin. And so the pin, now let's go ahead and close out the head. All right, so, and then there's assembly 2. All right, so I just have the 2. Tiling horizontally isn't bad. Whichever one I click in is going to be the active. And so the advantage or an advantage of the tiling horizontally is with both parts open, I can control select the cylinder, go to the cylinder in the assembly, and when I see that stack up of marshmallows, again, I'm going to get concentric to those bores. And then we can go ahead and hit OK. All right, as far as the rotation, let's see, this was, let's go ahead and save this. This was 1341 tie rod. and we'll save. All right, as far as its location, I don't want this to be able to rotate, but I do want it to stay aligned, so when I put the pin in, it's not as much of an issue. So again, I'm going to look for the front plane. It goes through the part, front plane of the assembly, and then those two can go to the mate and be parallel. All right, and then as far as where the pin is going to locate, and that will set the depth. All right, so kind of the assumption is that we're going to use that as the stop. I'm going to make that inside face and the pin go tangent. All right, so it has a location to stop at. All right, so one of the things that I need, okay, we're going to try the assembly feature last. One of the things that I would need here is for the clearance. We're going to see what we can find for that jam nut. All right, so either under the add-ins, we're going to turn on the toolbox. Didn't think I closed it, but let's check it in the design library. Nope, they're still open. We're going to find the nut. They did not give us a washer or anything. It's basically locating on that face. So the hex nuts. So I want to think that it is a jam nut, but we'll see if it gets big enough. And we need to look for the size. And it only goes up to 1.5 inch 12. All right, so hopefully there is piece, let's see, what was that one called out? Oh, that is a 1.5 inch 6. All right, we might still be in the game here. All right, so there is actually a 1.5 inch 6. We go ahead and hit OK. And then no, I don't want to continue to put in hex nuts. So one of the things I can do to hide a component in the assembly quickly is to click on the tab key on the keyboard, and that will allow me to hide that. And then to reverse it, we'll go with shift tab. All right, so we're looking for the pins. All right, and then I didn't really say, it's just a standard straight pin, so either a dowel pin unhardened. It probably will be a dowel pin. We'd want to press that in for the 1/4 inch. So I would say unhard, but precision enough. And the size, well, let's come over and we'll go up to 1/4 inch. And the length is 3/4 inch. We had 7/16 on the depth. So at least the first one gets us concentric. And then let's make this easier by picking the edge. All right, so in this case we have the geometry, but I'm going to go ahead with the face and make those coincident. All right, so we're going to have some variation there. And then if I hold down the shift button and hit tab, then the fork comes back, and we left plenty of room. So I don't know that I needed to make that deep. So if I want to save some of the manufacturing machining time, I'm going to highlight that face, try to determine where I placed it. Well, obviously before all of the fillets. Okay, and then we had a depth of 0.44, so let's pull that back to 0.312 and rebuild. And that'll update in the sketch, and we just saved a little bit, but it has enough relief over the top of the face. All right, so now for that assembly feature, we're going to see what we get here. All right, so I want to generate a hole wizard item from the assembly, and let's go ahead and look at it from the right side. I have to zoom back up on it. Okay, and so when we come across, we're going to find assembly features. We pick up the hole wizard. This was called out as a quarter 20, so let me fly that back in and we'll get the notation for it. And what they're saying is they want to run this set screw in and in place. So once this is pressed in place, then we go over to the mill or to the drill press and we drill a hole and we tap it, and then we go ahead and run the set screw on. So a 1/4 by 1/2 inch slot or set screw. All right, so there's my tapped hole. It is bottomed. It is also going to be a quarter 20. The blind condition, yeah, probably 0.65 for a 1/2 inch thread engagement. And then somewhere, let's do selected components, but no, I don't want to auto select. I want to make sure that I get the bushing and the sphere. That's in the head. So puts it in place. Let's go into the positions. And then I'm going to look for the intersection and select. If we can't pick up something interesting for the origin or for the center, then I will go to the center of the arc with a center line, and that is vertical and coincident, so that causes it to go fully defined. And then we're going to accept and put that geometry in place. Alright, so what I didn't pay attention to, notice that this shows up below the mates. It is a feature inside of the assembly. When we edited the feature, I probably jumped over. Whole Wizard's a little strange at this level. Propagate feature to parts. So do I want this to show up in the assembly drawing and make a notation there? Or do I want it to show up in the part drawing? So I think the assembly drawing is a better place for it. If it was geometry that I wanted to see in the part or to recognize in the part, then we would let it propagate. But I think it's okay being in just the assembly. So we're going to make sure to save. And then since we have a set screw, we'll go back in, find our bolts and screws. Let's stay with the slotted. And I would say a cone point would be fine. So it's not finding my quarter 20. We'll scroll down and, yeah, right at the edge of the screen, quarter 20. Length of 1/2 inch would be fine. And then we're going to, nope, we don't need to put in another one. Let's go with the edge and the face and make those coincident. And then as far as rotation, find an interesting place for it. We'll expand out, right click on the concentric and lock rotation. So again, concentric is the only one that gets to lock rotation. All right, so we have that in place, and there is our assembly. All right, so we have hardware fasteners. So I didn't call it fasteners last time. I'm going to call it hardware this time. And again, just off of screen, so I don't have any way to scroll that in, but right-clicking and just off screen, we're going to add to new folder. And we will gather those up as hardware. So what that lets me do is I can suppress or I can hide all of these fasteners if I need to in one shot by clicking on the hardware and going to suppress or coming down to hide. All right, so for geometry, let's go ahead with the exploded view first this time. So my explode step, I will pull the hex nut this way a little bit, and then we'll pull the pin that way a little bit, and then somewhere, I didn't think I hit it. Oh, did it not stay concentric? All right, so let's go ahead and make sure that the pin moves with. Both of those should have moved okay. And we'll apply. All right, so that's what I really wanted, was for it to stay in the hole so that I could come back and grab it this way and lift it out. Alright, so for the tie rod, we used a lot of the auto spacing last time. We're going to do auto space the components. Actually, let's un-auto space, and I will take the set screw, and we'll go ahead and pull the set screw out some distance. For that matter, yeah, I don't know that the auto space is going to help me with bushing. We'll go that way on the bushing. Alright, and then auto space for the head and the tie rod. Make sure that one stays selected. Alright, and then both of those move out. And then we can move them a little closer together. Alright, so if I go back and double click on the chain, 8 inches, let's see what 6 inches looks like. It doesn't look too bad. Go ahead and accept it, and that gives us our exploded view. Control 7 and save. Alright, again, the exploded view lives in the assembly underneath the configurations. Right click and collapse, everything goes back together. Alright, so a little bit different than the milling jack, but still has its share of complexities. So new part, new drawing. Okay, so drawing is optional. We made the adding the knurl and some of the advanced things in the milling jack optional. So the drawings are still optional here, and we're going to give it a view. And again, I don't know that I need everything. Last time I drug this in and I was getting the multiple views automatically. And these are going to be pretty small because it's 62 inches. Well, there's not a whole lot we can do with it. And it is fairly narrow. So I'm going to Control C on the isometric view. And then when I have the exploded, it will show the checkbox, and it will let me perform the explode. Alright, and then under the exploded view, let's bring that down a little bit, just looking for some place where that looks nice. We're going to right click, and it's kicking me off of the screen again, so all the way down to tables. Under the tables, we'll go to the bill of materials. There's no sub. Oh, and I didn't import anything yet. So I'm still with the center lines. So let's go ahead and make sure that's highlighted. And towards the bottom then, I see that the layer, let's go ahead and put it on the dims layer, so fix those up. And then the description, I'm not using the description at this point, so if I right click and select delete and column, that will kind of close up. Oh, I'm changing my column thickness, need to be on the arrow. Alright, so we'll move that out a little ways. And then I want to go for the auto balloon. And I think on this one, because of the size, we're going to load it all to the left. Accept, and we'll figure it out. Oops, I still left it in the center. So let's go find the balloon properties and go into layer. And then we're in dims, or we're in dims now anyway. Alright, so pretty small, but we have our geometry. I'm going to go ahead and hit save. And then let's see what else is open. We have the pin. No, that's not really going to help. I want to go through this again kind of quick, so let's do the tile vertically. So if I go back to the list in the assembly, we'll bring in the head first. It goes directly into create multiple views. I don't know if I need all of those, but we'll go ahead and accept it. Looks like it's picking up the first page scale, so that'll be a little interesting. We'll bring in the bushing. Again, I don't know if I need all those views, but we're going to insert them anyway. We'll bring the tie rod in. Pretty sure the tie rod I only need, let's go with those two views, and I'll explain my reasoning when we get back to that view. And then the fork, that one's going to be a fun one. It's a dimension. Go ahead and accept. And then we'll put in the pin. Nothing I really need to do with the hardware. Yeah, we're probably going to need the three views on this one just because of the pin location. Alright, so go ahead and expand that out. Our 1 to 20 size, let's just see what it looks like 1 to 1. Okay, it's a little bigger than that. Half size, not too bad. Alright, so we have something that we can dimension. And so one of the notes would be to come back to the spherical. So found the spherical, and it's still in center. So before I get going on the dims, make sure it's in, out of the center and into the dims, pick up my silhouette edge. And we weren't exactly given a spherical radius for that, just the 3/16. So in that case, that becomes for reference. At least I'm thinking it's for reference for now, so we'll denote it with parentheses. Go from. If I hold down the shift button, I should be able to pick up that silhouette edge again and go right to. I have a little screen flip hanging over from the assembly. Let's see. Zoom? No. Let's see if I can jump this in and make it go away. Maybe not. We'll be working around that one for a little bit. It should go away eventually. Alright, and then we want to, let's see, will the whole wizard pick it up? Well, 1.75, no, that doesn't help. Was it 1.75 or 1/2? That was 1.5, so the outside was 1.75. Oh, you know what? That is probably because it's too big. Alright, so let's go back in. And that was why it showed it neck down. Alright, so going back into the revolve. Alright, so I left it at that size. Let's go with 2 of the split lines. And then hopefully the dimension stays. Alright, so I'm going to get rid of the collinear. Let's check there. And that dimension did apply. Let's see if I can move it over to. Alright, so I changed location by grabbing onto that handle and moving it. And so this needs to stay horizontal. Let's see, that one picked up a collinear, or was remaining collinear. And then this becomes horizontal. Alright, and then the major diameter is 1.5. Okay, so since it didn't bark at me, let's go ahead and escape. And we had 1.25. So from the end of the sphere, we said that was 1.062. And actually having that blend into to an angle, but it's not really. Oh, it was a 45-degree chamfer. Never mind. All right, so I missed that dimension as well. So 45-degree chamfer at that lower edge. All right, so that can go in. Pull up the 45 degrees. See what that does to the build. Looks a little better. And we'll have to see if that did anything on the drawing or the assembly. So probably just need to jump back into the assembly, let it rebuild. No errors. All right, so it didn't do anything real bad. Probably should have been able to catch it with the hex nut that pin was really that big, but I wasn't quite looking for it. All right, so just a few dimensions, few places to go. Our overall, and again, I'm looking for that silhouette edge, so I'm going to hold down the shift button, and I find the little cylinder with the line through it that gives me the silhouette, and then I'm not going to have to go to a max condition. All right, so I'll get a few dimensions to start. For the pin hole location, we'll go with the hole callout. It's on center line. So if I pick and tell it center line, we need to select the view. There it comes up with the center line, except it's not on the correct layer, so we'll switch that over to center. And then now we can bring it back to 0.375 off the end. Okay, so a few more dimensions to add. Let's see, let's go ahead through and do a 1/5. That's pretty wild. We have lots of tangencies. Sheet 4. Alright, so I said on this one I would explain what I want to do is rotate this view 90 degrees. And when I rotate it, instead of the right side view, that will become the end view. Now we haven't applied any dimensions, so I'm not worried about that. I do want to show this a little bigger. So at 1/5, well, the isometric, not so much. So we'll use a custom scale and we'll go back to at least 1/10. We can make that fit in the side. All right, and then for this one we want to use, we'll go back into, see, nope, make sure it's not on this one, on the break view. Since this is long, we're going to have a cut direction, a vertical. What do we want it to look like? A straight cut, a curved cut, jagged zigzag, small zigzag, or the jagged. All right, gap size of 10 millimeters, 0.39. We're going to place the first gap, place the second gap, and then it's going to shorten that up to where we can actually do something with it. All right, so the callout becomes an issue. I'm kind of surprised that it didn't put the callout in. We're finding it, but in this case I'm going to have to go with the, what did we have, 2, and it would probably make sense to put at least a few more decimals on that one. 4.5 UN course, 2B thread, and left hand. At least I hope that's the left-handed in. Alright, we're going to come back over here. And I don't know that I need to specifically call it out as a right hand, but just to make sure that we don't have that confusion, I probably am going to just leave it. Now, I wrote those in, so if this changes, I'm responsible for also updating this print. Nope, I don't need the print, I need the note. Okay, not sure why it's keeping that one. Let's just go into the dimensions. Still having some video card issues. And we'll give it, I really would like to have the point. Okay, so since that's being difficult, well, mainly it's not exactly something that I should be selecting anyway. Alright, so get me out of the dimension. And the depth of the thread or the length of the thread we can put in. Let's see, I'm not seeing it show up, so let's go into the CL. Huh. Now let's see if we can find a modifying symbol, more symbols. No, wasn't a draft, don't really have GD&T. And we'll just go with the, well, and so this end was 3.00 to the end. Come back to the center line, we'll look for that again. Oh, it stayed in whole center. This one was 3.875. All right, so I'm not sure if that's the best convention, but there we go. All right, so smart dimension, we'll come back to our geometry, find the hole, or find the cylinder, that looks like. And because the helix is generating that geometry, then it becomes a little stranger to select. All right, so we'll position this. Okay, think it's happy where it's at. Oh, and then the overall, because we're in the break. Okay, we'll come back. And we have the 62 inches. All right, so we'll get these organized, make them look a little cleaner, 1-to-1. Maybe not. That wouldn't be too bad. Oh, I said the notch. So we'll bring up a detail view on the isometric view. Let's just go for custom scale. We'll reduce it down to 1/2 and kind of move it over into the corner. All right, so on my next pass, then this would be where I want to bring in the model items. All right, so for the entire model, import into all views. Now let's go ahead and select the view. I think it's only really going to be on that view anyway. And we'll go ahead and hit OK. So that gives us the view. Main thing here is that we're going to switch it over to 3 decimal places and accept and accept. All right, and then material length. All right, so pretty close. And then back into the to the geometry, same thing. Probably we need to stay with the 1/5 because it's pretty good size. Might be able to get a little closer, but that will give us the geometry. If I wanted a section view, I don't know. Well, let's try the bottom view first. If that shows detail, we'll go in to the view layout, grab the projected view. Front view is selected, and we'll place it. Center line switches over to the center layer. And then on the off chance that the whole call out, not feeling warm and fuzzy, but let's go ahead and see if it'll grab. So 1 7/8, no, probably not. So we're going to have to put that that same annotation. And I did not put the 2A or the, or did I put the 2A on that one? Probably put a 2B out of habit. All right, so this becomes a 2A external thread. All right, and then I'm going to go ahead and copy, so Control-C on the keyboard, then I can jump back to this sheet, and we'll go with the annotation. And I will have to look into if there's a way to match these. And so this is the 2B left-hand thread, 3 inches deep. All right, so then if I wanted a section view, and would the section view include or not include? All right, so let's just go ahead and pick the section. And this is going to be a vertical cutting line. We'll look for the midpoint. Okay, and then accept it. Oh, I didn't mean to hit undo. There we go. And we'll drag it off to the side. And that will give me the section view with that geometry. All right, so dimensions that we have. We'll go ahead and save the drawing. And then we would go back through, we would apply the materials. We can do the materials real quick. The 1045 is still looking pretty popular. So the jam nut, not too worried about. We're going to make that a purchase part, standard steel purchase part. The pin is called out as 1045, so just off screen, let's see if I can move that up a little bit. All right, so 1045 coil drawn. The fork then should be calling out a drop forging, so I want to say that I'm not sure what material that would be. I'll have to research that one. So let's make it a plain carbon steel at least, so it picks up a description. Then the tie rod is 1040 with a heat treat. So if we can't find 1040, we'll stay with the 1045. So in this case, I'm going to manage. We have 1035, stress strain, 1020. I think we'll just stay with the 1045. And a lot of this is going to have to do with availability and does it need to be at that level. So, and then the head is also listed as a drop forging, so we'll go with plain carbon. All right, and that gives me the geometry. So save it, and then back into the part. Now, again, since I did not apply anything at the assembly level, we do need to open these parts up, so I can right-click on the part or right-click on the component and then edit. All right, so material goes in, we apply it, we save it, and then I can close and go back to the drawing sheets. And at least for that one, since we opened it and applied those file properties, then we'll have the part, we'll have the plain carbon steel. So one more save. Yes, and then we can close it. All right, so last thing I want to do on this group is kind of an advanced topic, and again is optional, is looking at interference and clearance detection. So part of our stack up is when we were looking at those values. Oh, I didn't apply to the bushing. Let's find that phosphorus bronze, bronze material anyway. So we'll just come over to the copper alloy. See if there is one in here. No, magnesium, rock copper, tin bearing bronze. Well, we'll stay with the phosphorus bronze. Okay. So the interference detection is we're going to pick a couple of components. And so between the head, results may be affected by your changes. Click calculate to update. So we click on calculate. And it should show me that at my maximum material conditions, there is a volume and there is an overlap of geometries. And so on the fork, where it exists, what it is doing on the top level, and it's giving me those volumes. All right, so coincidence as an interference, show ignored interferences, subassemblies as components, fasteners. We already created the fasteners folder. All right, so let's see if we can identify some of these. Interference 5. Well, there is the set screw. It's engaged in the geometry, so that one would be considered with the fastener. That would be on the other side. All right, and then we get to the head and the bushing, and there is an overlap and interference. So we know that that was desired because of the press fit. At 3" on the hole and 301 on the bushing, at the very least, it would be 1/1000th of a press fit, and 3/1000ths if we went to the upper end of the tolerance. Let's see, 3001 to 302. Now it would go from a light press to a press of about 2/1000ths, which is still pretty substantial on a 2" diameter. All right, the other one then would be to check for clearances, clearance verification. If we go back to the head and the bushing, selected items and calculate. Calculate to begin the clearance. What are we doing here? Get that back, minimum acceptable clearance. Well, we're not going to do anything there, so if I calculate it, it's going to tell me that I do not have any coincident or interfering. So another way of checking that we have that press fit. All right, so I mentioned early on that we had mass properties. All right, since I have most everything except for the hardware has been applied with a material, then when I go into the mass properties, the origin was back up here at the head, and report the coordinate values relative to the default, which is the origin. And so the mass of this is 111 pounds. We can switch our units over to kilograms and see what this is in metric units. Have the volume, have the center of mass. So where the graphic is at that location, that's the center of mass. And so on the CSWA, the center of mass and the mass would be the two items that you would get asked to provide for answers the most. So knowing where to get to the mass properties. The other one would be to take the measurements at 0.62. I don't want to fight those too much. But if I was given a certain value, maybe I would measure between the two faces, and that measurement is 55 inches. All right, so just kind of depends on what stack-ups we're given or what geometry. All right, so we're going to save that out. We will call this one done and be ready for another set of assemblies.